Hello everyone, my name is Deepa Bajetha. I am working as an associate professor in IIMT College of Pharmacy, Greater Noida. Today I am going to discuss about the topic radiopharmaceuticals. These are the topics: radioactivity, measurement of radioactivity, properties of alpha, beta and gamma radiations, half-life, and radioisotopes and the study of radioisotopes. Sodium iodide I-131, storage conditions of radioactive substances, precautions and pharmaceutical application of radioactive substances, and last one is measurement of radioactivity. So first one is, what is radioactivity? The phenomena of spontaneous emission of certain kind of invisible radiation by any certain substances is called radioactivity. The substances which emit such type of radiation is called radioactive substances. Accidentally discovered by Henry Becquerel, further modification were analyzed by scientist Rutherford. So there are the number of radiations which are emitted. First one is alpha rays which have positively charged, beta rays they are negatively charged, and gamma rays they are neutral in nature. So any nucleotide which is not radioactive in nature is regarded as a stable. So to be stable, a nuclide may possess appropriate energy. Those nuclides which undergo spontaneous nuclear change so as to attain stability by emitting these radiations are called as radionuclides, or we can say that they are radioisotopes. So what are the units of radioactivity? First, first is Curie, which are denoted as a small c, defined as quantity of any radioactive substances which undergoes the same number of disintegrations in unit time as 1 gram of radium and is equal to 3.7 into 10 to the power 10 disintegrations per second, TPS. Second one is Rutherford, which is denoted as capital R, is equal to 10 to the power 6 DPS. DPS is disintegration per second. Third one is Röntgen. It is the unit of exposure. 1 R is equal to 2.58 into 10 to the power minus 4 coulomb kg. And next is RAD, radiation absorbed dose. It is the unit of absorbed dose. Pharmaceutical dosage forms are described in RAD units. 1 RAD is equal to 10 to the power minus 2 joule kilogram inverse. And fourth one is REM, Röntgen equivalent man. It is unit of dose equivalent. RBE, relative biological effectiveness, shows effect of radiations alpha, beta and gamma on the biological system. Becquerel is the SI unit of radioactivity, defined as 1 disintegration per second. Next is, what is isotopes and what is radioisotopes and radioactive isotopes. So first is isotopes. Isotopes are basically the atoms with having same atomic number but different their mass numbers. Radioisotopes Radioisotopes of an element can be defined as atoms that contain an unstable nucleus and emit radiation in the form of alpha, beta, and gamma rays. So they are the examples of isotopes. For example, uranium. Number of protons in uranium is 92 and number of neutrons in uranium is 143. Another example of uranium is number of protons in this having 92 and number of neutrons in this 146. So isotopes of any particular element contain the same number of protons but different number of their neutrons. Next is, what is the properties of radioactive isotopes? Radioactive isotopes are having emit radiations, second half-life, third penetration properties, and fourth one is same chemical properties, and fifth is different physical properties. So first is emit radiations. Radioactive isotopes are unstable, so they undergo radioactive decay and emitting radiations till they become stable. So type of radiations, first one is alpha particles, second one is beta particles, and third one is gamma rays. These are the radioactive atoms having energy radiations. First one is alpha rays. So what is alpha rays? Alpha rays have low penetrating power and having positive charge and can be detected by a strong magnetic field. Also, alpha rays carry two positive charges and have a mass of 4 atomic mass unit. Heavy metals have capacity to emit these type of rays. All alpha particles are having the same energy in alpha rays. Penetrating power of alpha rays is less as compared to the other type of radiation like beta rays and gamma rays. So alpha rays have less penetrating power as compared to others. So because of low penetrating power of alpha particles, these elements which emit alpha rays do not find use in biological applications because they cannot penetrate tissue. Second one is beta rays. These have two types. First, electrically positively charged particles which are called positrons. Two types of beta rays, positrons and negatrons. Positrons are those basically which have positive charge. Negatrons those which have negatively charged particles. So they have great penetrating power than that of alpha rays. So alpha rays have less penetrating power and beta rays have more penetrating power as compared to alpha rays. Beta particles have negligible mass, usually accompanied by the gamma radiations, have less ionizing power than the alpha particles. Alpha particles have less penetrating power but they have more ionizing power as compared to beta rays. And third one is gamma rays have been more penetrating than alpha and beta rays. Gamma rays have more penetrating power as compared to alpha and beta and very poor ionizing power. So gamma rays have the same character as that of very short electromagnetic waves called X-rays. And gamma rays have no mass or no charge produced during disintegration of radioactive substances along with beta radiations and during nuclear fission. Nuclear fission means atoms are split apart which releases energy. So they are uncharged and have poor ionizing power. So next topic is what is half-life of radioisotopes. Half-life of radioisotope is the time period required for any radioactive isotope to decay or disintegrate to one half of its initial value. Again, I am repeating, half-life of radioisotope is the time required for radioactive isotope to decay to one half of its initial value. It is abbreviated by the T half. T half is equal to 0.693 by lambda. Lambda is decay constant, disintegration constant, a characteristic of a given isotope decaying in a unit time. So, what are the radiopharmaceuticals handling and storage conditions? So, great care needs to be taken in handling and storage of radioactive materials for protecting people and personnel who handle it from the harmful radiations they emit. Precautions have to be taken while working with detectors, tracer equipment, radioassay, manufacturing or handling of radioactive materials. In order to have protection from hazards, of radiation, radioactive materials must be stored in an area not frequently visited by the people. Shielding may be required during using or handling of radiopharmaceuticals. Thick glass or persec containers provide sufficient shielding to protect from the gamma rays which have high penetration power. Lead shielding has to be used. The storage area must be regularly checked for the radioactivity. Radioactive liquids. Working area should not get contaminated with the radioactive material. If radioactive liquid is to be handled, it must be carried in trays with absorbent tissue paper so they any spillage will get absorbed by the paper. Next, we can use rubber gloves also while working with the radioactive liquids. Pipettes operated by mouth should never be used. Waste of radioactive material has to be stored till its activity becomes low and then only it should be disposed. One should not touch the radioactive emitter with hand, but it should be handled by the means of forceps. Smoking, eating, and drinking activities should not be handled in laboratory where radioactive material is handled. Sufficient protective clothing and shielding have to be used while handling of radioactive pharmaceuticals. Radioactive pharmaceuticals or materials have to be stored in well-labeled containers, covered or shielded by the lid bricks, and preferably in a remote corner. Areas where radioactive materials are stored should be monitored and tested for the radioactivity regularly. Disposal of the radioactive materials should be carried out with a great care. Strict requirements are prescribed by the Department of Atomic Energy DAE for the establishment of the radioactive facility in the hospital or pharmacy. These include specification for premises, storage, space, working area, disposal protocol, training of personnel, periodic check on contamination or leakage. So next is what is the use of sodium iodide 131. So sodium iodide 131, it is used as a diagnostic aid for the studying the functioning of the thyroid gland. The radioactive pharmaceutical basically used in the treatment of cancer or cancer related disease. Used in scanning the thyroid for determining the size, position, and possible tumor location. It is used in the treatment of severe cardiac disease, which reduces workload on heart. Radioactive iodine in thyroid carcinoma, that is cancer, the isotope is used most frequently after the surgical removal of cancer to treat any residual tumor tissues. They used in medicine in four different ways. First is radioisotopes are used in therapy, emitted radiation used to destroy cells in condition like cancer. Next is radioisotopes in diagnosis, radioactive tracers. Third is in research like biological and medicinal studies by the use of radioactive isotopes as tracers. And next is sterilizers. For the sterilization purpose, we can use radiopharmaceuticals or for the surgical instruments. So first one is the application of radiopharmaceuticals in therapeutics. So therapeutically used radioisotopes have been found to depend mainly on their ability to ionize atoms. The energy measurement involved in the radiations and resulting in the ionization may be expressed in millions of electron volts called MeV. The strength of alpha, beta, and gamma rays in expressed in MeV, all radiations bring about ionization of atoms in their path. The radiation of short wavelength like gamma rays is having high penetrating power than long wavelength like beta rays. The method of therapy is called radiotherapy. It can be used for both benign and malignant cancers. Examples. So gold 198 AU is used in the treatment of abdominal and pleural effusions associated with the malignant tumors. It is given in the form of colloidal gold suspension. Gold 198 AU also used in the treatment of carcinoma of uterus and urinary bladder. Cobalt labeled cyanocobalamin, that is vitamin B12, is used in the diagnosis of pernicious anemia. Sodium iodide preparations finds use in the treatment of thyroid disorders. Calcium is also used to study bone structure and in carcinoma of bone. Strontium 90 is used in the diagnosis of superficial carcinomas. Next is in the diagnosis. In diagnosis, radioactive tracers find use in medicine for the diagnostic purpose. Second is labeled cyanocobalamin find use for the measuring the glomerular filtration rate. Ferric citrate injection finds use for the diagnosis of hematological disorders. In diagnosis purpose, colloidal gold injection In diagnosis, colloidal gold injection is used diagnostically to study blood circulation in liver. Sodium hydroxyphosphate injection finds use in the study of renal function. Sodium rose bengal injection find used as a diagnostic agent to test liver function. And in research, excellent biological and medicinal studies have been carried out with the radioactive isotopes as tracers. In sterilization, radioactive pharmaceuticals used in being made of radiation constantly available from strong radiation source for sterilizing pharmaceuticals in their final pack containers and surgical instruments in hospitals. No heat or chemical get involved. Thermolabile substances like vitamins, hormones, antibiotics can be safely sterilized with this radiopharmaceutical substances in sterilization process find use in the sterilization of pharmaceuticals. Next one is measurement of radioactivity. To measure the radiations of alpha, beta and gamma particles, many techniques involving detection and counting of individual particles or photons are used. The method selected for the measurement of radioactivity depends upon the extent of energy dissipation and penetrability of radiations. And the number of gas ionization devices which are used for the measuring of radioactivity. First one is ionization chambers, proportional counters, Geiger-Müller counter, scintillation counter, autoradiography, and solid state detectors. Thank you.